Every single time you take a med, you have to take this.
This is our Catalytic Converter Lab on the 1999. What is this, the Accurate TL?
Indeed it is.
Our initial temperatures were 74 degrees Fahrenheit before the cat, and after the cat was 70 degrees. We shall now start the car, which is lifted off the ground with the proper safety equipment in the rear to ensure we all don't die from those lovely, lovely gases, and take temperature readings every 10 minutes, or every minute for 10 minutes. We are now reaching our 1 minute mark. Record.
Welcome back for our 1 minute mark. We have 113 pre catalytic converter and 77 post. Welcome back for the 5 minute mark. We have 223 for the pre. 135 for the post. Welcome back for the 10 minute mark. We have 293. And 308 post. Alrighty, welcome for our 2,500 RPM test. We'll be taking a reading every minute mark. This is the 1 minute mark. And we have 349 for the pre. 361 for the post. At the 5 minute mark, we had 415 and 477.
For this portion of the lab, we're going to be measuring the exhaust temperature, starting at our headers and going all the way to our exhaust tip, and measuring at 1 foot intervals.
Well, we don't got no headers, Dylan.
You know what I mean? Yeah, we do. We have headers. It says headers on it. And it's headers because there's 2 of them, not headers.
Bitch.
So we are at 400 degrees roughly. Right here, at the header. Bitch. Next, we're gonna go under the car. We got approximately 404. Another foot down. 455. That is right before our cat. Right after our cat is 453.
Scooch.
About another foot down. We're looking at 410, 412. After another foot, we got 457. After one of our mufflers, 373. Right before our Y pipe to our mufflers, we have 236. And the tailpipe, we have 230 on one side.
230, 230.
And $75 on the other, for some reason.
All right. I think that. Hello, and welcome to our questions for our thermometer, our thermometer questions. All right. Some people might ask, Jared, what are the normal inlet and outlet temperatures for a catalytic converter? Now you see your inlet temperature is going to be a little bit cooler than your outlet. Approximately 10%. Your outlet's going to be hotter than your inlet. All right. Next question. How long does it take to fully warm up a catalytic converter? I mean, it just depends on the system. For this one, we still didn't really even get all the way warmed up. We want to see light off temperatures, which are about 500 degrees. And that's when your catalytic converter is going to work at 50%. And when we get light on temperatures, that's about 1,000 degrees. Then we will get full efficiency of our cat. But we did not achieve that in this lab. Second, next question. Where is the hottest location in an automotive exhaust system? That's going to be right after your catalytic converter, your outlet. And last question here. What is the normal temperature drop in an exhaust system? I mean, it just depends on how long you've been running the system. I'd say for
50 degrees a foot?
Yeah, 50 degrees a foot. That'd be pretty good for me. That's what our test results showed. All right. Hope you enjoyed. Welcome. Today's a new day, and we'll still be talking about our 1999 Acura TL. Today we have the decade resistance box hooked up to our mass sensor. And that is on our sensor side of the circuit. And we have a 10,000 ohm set up, so 2,000, 2,000, 2,000, so on. We also have our scan tool hooked up right here. It's going to look a little bit different than last time, but we're going to be looking at our map and our short-term fuel trim. And yeah, that should be what we're looking at right now. So we're going to start off increasing it. We're going to go up to 4,000. As you can see, our short-term fuel trim really lowered itself since our engine's under load. We go all the way up to 10,000. You can see our short-term fuel trim really taking a hit right there. Anything more than 10% is considered not so good. Now, if you just want to keep it on that, I'm going to drop it all the way down to 0. Also messing with our calculated engine load too, and our spark plug. You see we got back down to 0. I was pretty happy now. Welcome back, and we are still hooked up to the map sensor, and we're looking at our short-term fuel trims as long as our air fuel and our O2 sensor. Our O2 sensor is pre-cat, our air fuel is post-cat. Pre-cat, post-cat. You can see how the cat likes it whenever you make it lean out. Yeah. So we're going to be adding resistance. And as you can see, short term is definitely taking a hit, and it was up there before now, and now it's going down, showing that we are leaning out. Our voltage is falling. We did also notice that we do have an open so it thinks that we're wide open throttle, but we're definitely not. So
Throttle is showing up
not
here
too happy.
as 100%.
So we got 100% throttle. And if we look back at our map sensor, it'll say, it's not going to say it's taking as much as it is because it does reference off another sensor. But yeah, short terms, all wonky. Engine loads 28. Spark gauge is a little bit more retarded, but yeah. Turn it back off. Now we can see our short-term fuel trims coming back to normal. Starting to lean out a bit. Reaching back up. There we go. Now she's a little bit more happy. We can see when we did that, the map sensor did go back to a somewhat standard value. Hello and welcome to our lab. We'll be looking at our O2 sensors right now. and we'll be looking at the lambda and the voltage on it. So right now we're running pretty good lambda, as you want to see 1% lambda, and if we up the IAT to 284 degrees, as you can see, the lambda went all the way up to 1.1. So if we look at our O2 sensors, we're going to be reading the voltage right here in lambda. Lambda is just stoichiometry, 14.7% parts air to fuel. And yeah, right there we have our voltage and lambda. So let's go ahead. Right now we're at about room temperature, just about 80 degrees. And so we're gonna up it. We're gonna drop it all the way down to like 10 degrees Fahrenheit. As we can see right there, it gets real rich for a second. And then it starts averaging back out. As you can see, real rich, because it thinks we're in cold air, so it dumps more fuel in. So cold air is denser. All right, now let's lean it all the way back out. Let's make it 284 degrees. As you can see, this is going to shoot down.
And that goes up again. It goes up past 1.
Yeah. It's just not happy right now. We're switching it too quick. As we can see over there, amp down. But yeah, that's the basic operation. It's what you want to look out for. Yeah.